Welcome to The Builders, a Postgres podcast. I'm your host, Gulcin Yildirim Jelinek, and I am excited to kick off this series where we explore the trends in Postgres, data, and AI world. In each episode, I host one distinguished guest to delve into the intricacies of Postgres technologies and their real-world implementations. Today, I'm thrilled to welcome our third guest, Gianni Ciolli, VP for Solutions Architecture and Field CTO. Welcome, Gianni.
Welcome, Gulcin.
And we know each other for I don't know how many years, since Second Quadrant. Even before I joined Second Quadrant, I knew about you because you were more prominent in the community just before I joined as well. I think more than 10 years already we know each other. We were colleagues within the two companies now, and I hope for longer time to work together. So for me, it's great to work with you. So welcome again. I'm really happy.
Yes, I was born before Postgres, actually, so I've been around a while. And I don't know what is my version number, but yes, we've been working together for so long, we don't remember the year, actually.
That's true, yeah. The year is like, wow, what's just a number. Okay, so you can introduce yourself a little bit. Like, how did your journey as a Postgres person start? Like, how was your first encounter? How did you stay?
Yeah, it's a long story. It started at university in the 90s, which is actually where I was studying mathematics in Florence, near Prato. Prato is an important city for Postgres, as we all know. I did learn open source there and Linux. I installed my first Linux by downloading floppy disks with the help of the other people in the know around. And that's how I got to found the Prato Linux user group together with some friends, including some colleagues like Gabriele Bartolini that we all know. The Prato Linux user group started organizing Linux days, which was a common thing in Italy back then. We are already now like 2001, 2002, these years there. The Linux day was quite successful because I suppose we were good in organizing Prato, very methodic. So we had about 15, 20 volunteers that will come and help every year organize this thing. People will bring their own laptops. There were no laptops back then. People will actually bring the big computer and we will install Linux on them. We also got support from the local council, which recognized our potential, let's say. And then at some point, Gabriele, I had moved to Rome for family reasons in the meantime. Mm-hmm. The group of people that organized the Prato Linux user group, they were called to a new challenge of organizing the PG Day. The first PG Day was 2007, I think. And I didn't attend that one because I was in Rome with a small child. And, that's actually where we got to meet Simon Riggs, and also to meet, to enter the Postgres community. It was, I think, Postgres 8.3, if I'm not mistaken.
Probably something 8, yeah.
1 year later, we organized again big Postgres conference in Prato. This time it was multiple days, and there were many people from the community came. We did actually participate at Second Quadrant, which by then was created. After that conference, many of the prominent people in the conference decided to found Postgres Europe, and then that's how things went from then. Replication, scalability, and everything.
I liked reading the story. You were there before Second Quadrant was founded, before Postgres Europe was founded. So I'm like, wow, you were just there. And if anybody's listening, of course, Simon, Gabriele, hi to them too. I think they are like really important people in the Postgres community and personally for us as well. Respected friends. Okay, so wow. I know you worked. I mean, you must have worked in the exciting projects, challenging projects when it comes to Postgres. So which ones you would like to maybe mention, like kind of your story about how you are with Postgres and what kind of projects you were working with?
This is an interesting question because retrospectively I can see how I actually ended up focusing on one field. So most of my Postgres work was in high availability. Mm-hmm. I did work together with Simon Riggs in adding a hot standby to PostgreSQL back in 2009, was then released in 2010. Then I did work high availability related projects like, writing some pieces of Rep Manager, writing some little contributions to BDR, which is now called PGD, Postgres Distributed, EDB Postgres Distributed. Then I also did contribute some pieces and use a lot TPA, which I think is fundamental tool for high availability. It's not a high availability tool. It's a tool that allows you to deploy and install, configure a cluster and maintain it in a declarative way and in a repeatable way. And it's very important for high availability, because high availability is that part of Postgres that you cannot test with a single Postgres. So if you want to work on high availability, you need the ability to set up like 5 or 10 different Postgreses, possibly on different IP addresses with network between them. Sometimes you have to do it on the cloud, sometimes you can do it on your laptop. So it's the bureaucracy will overwhelm you unless you have some sort of automation.
That's true.
And the risk is also, if you don't have some sort of automation, you create your own homemade scripts, but then you always end up testing the very same configuration, which is always the same, and you miss a lot of bugs and issues. So it's really important to do availability with this tool. It even has a feature where you deploy on Docker containers, not the microservices. These Docker containers are like little VMs on your laptop, and you can mount the local directory, the source code directory, on those containers, and then it compiles on an overlay file system, and it builds the cluster using those executables. So what does it actually mean? If you are hacking on a tool, like I was hacking on Rep Manager, trying to add a new feature, with this feature here, you can change the source code, write a tpexec, rebuild sources, and then 4 seconds later, you actually see the new code running on the cluster. So it's if you have to do it yourself, it will take, I don't know, ages and mistakes, because I tend to make mistakes when I do the same thing over and over, because you get bored,
Yeah.
But computers don't get bored, so they're excellent for automating tasks.
That's true. Like, I think you actually bring me to a topic that I very feel familiar with as well. I'm very familiar with it. So TPA,
yes,
yeah. It was like, for me, when I started second quadrant, I started as remote DBA. So what remote DBA was doing, that you are DBAs, but for other companies. So we had customers, for the people who doesn't know what we were doing in second quadrant. We were building our own tools like BDR, now PGD, and also we started TPA project that Abhijit, if he's hearing, also hi from us to him too. And he said that, we are starting this deployment tooling project, and we'll deploy Postgres clusters, as Gianni was describing, to achieve HA. You can't really have one instance and do everything in one instance. You need to have multiple. You need to have replication, backup solution, high availability on these clusters, and you can configure things automatically. So we started from a simple architecture, and then from then on, we added more features and made it a big tool. So maybe for the people who doesn't know TPA, we can actually mention it as well a little. It is open source now in EDB repository. You can see it's the trusted Postgres Architect. And for us, it's a project where we built overall more than almost 10 years now. So it is tested in many customer scenarios that you can just build up Postgres clusters in either in bare platform or in, as Gianni was saying, in Docker or in cloud. Anywhere you wish, and you can set up the networking in between, set up the tooling, use the suggested configuration that we already have there, or you can just add your own. It's highly customizable as well, but it also comes with good practices that we recommend as Postgres professionals. So that's my story with Abhijit said that, okay, we are starting this and you should work with it too. I was like, okay, and then I kind of stuck with the project. I couldn't leave it. I left the project, come back to it, and yeah, it's for me, it's personally also important. And how do you use it?
It's a story.
Yeah.
Right. I think it's a story of life. Lucky people, they are lucky because they get to work with interesting things, but then they get stuck with them for ages. I mean, I started with databases with Postgres, and I stay with Postgres after almost 20 years. I'm still with Postgres. I have to say that I didn't get much overrun with the other databases because I didn't need to.
Yeah, exactly.
I'm probably the most anti-pattern person in databases because I started with one company, probably end with the same when I retire and go doing something else. But I also did something else before Postgres. But going back to TPA, I think it's really important because it's an open source tool that everybody can use. So it can actually be used as a foundation for any activity, in the sense that it's not limited to customers or to people with a certain subscription or with a certain contract, which means it can become a foundation, right? So, obviously, one use case of it is to test things before you actually say them to somebody else. So if you want to write a tutorial on how to do failover, you probably want to actually do the failover before you tell people to see that that what you're telling is true. You can have some project truths, let's say, where you want to be to say some things that are true, because you get to have more friends in the longer term if you say things that are true, right?
Yeah.
And then, of course, integration testing is a very important topic, and a topic that's very undervalued usually, because integration testing is exactly the kind of problematic activity where you have to put together different things, and it's a point where you see the difference between theory and practice. You know what is the difference between theory and practice? In theory, they're the same. In practice, they're not. And theory, all things should work together. Why? I get a functioning plate, a functioning fork, and a functioning knife. I can have a functioning lunch. But in practice, you put them together, and the fork is incompatible with the version of the knife, and the plate doesn't cook because you forgot the library for the. You end up you will not eat, because of these inconveniences. That's actually why integration testing is important, and having TPA allows people to no longer worry about it, because it's effectively one-liner. But also, look, we were discussing before about writing, being able to deploy replication clusters. I firmly believe that you cannot design a bicycle unless you can already ride a bicycle.
Exactly.
Right? If you don't even know what a bicycle is and you never use one,
Yeah.
how can you possibly design one? You see these things that are designed by people that don't use them. They're horrible. I mean, I was given as a gift a bowl for fruit, I suppose, because it looks nice. Then you use it, and then after a while you have to wash it because you're for obvious reasons. I put it in the dishwasher. The shape of the bowl is such that there is no position
that it can
be washed.
Okay.
No, it fits in the dishwasher, but there is always water because it's designed in a way that there is no orientation that the water falls out. There's always a little lake of water somewhere. So it's inadequate for dishwashers. This was designed by people that probably have a lot of money and pay somebody else to wash their dishes, and they don't worry if it's complicated of waste of time, because it's not their problem. So, to design software, you need to use it first. Definitely. This is why it's so important to have TPA. And that's why we use it for training our colleagues, right? So before people face customers or do work, they can experiment with this tool, pretending to be in front of a customer, and without wasting half an hour setting up together, they can bring up a cluster and show failovers, upgrades, switchovers, and everything. And of course, it's also important for developers to focus on the solution rather than on the tool, because to develop Rep Manager feature is not so, well, it is important because the feature is the brick in the house, but you don't say, I live in a heap of bricks. You live in a house because that's a solution that you want. Yeah, my house is probably made by 3,000 bricks, but when I think about the house, I don't think about the number of bricks. I think about the function that it solves of letting me do podcasts, even if outside is 5 degrees, which is the case at the moment. So with a tool that allows you to deploy the entire cluster, you focus on the solution and not on the individual instrument. Like a philosopher was saying, when I point to the moon, don't look at the finger, look at the moon.
That's true.
Right? So that's the real goal.
Yeah, you sum it up pretty well.
Yeah, there's many other things, right, about the software, but it boils down probably to the testing in the right way. There's another few points, like I discovered recently that I like YAML very much because it allows me to mix code and comments. As I grow older, I dislike increasingly documentation. That it's only documentation. I don't like particularly to read 300 pages of instructions without that cannot be tested, because there's a lot of content, and when you write about mathematics, about the Pythagoras theorem, it's still valid after 20 years. But if you write something about installing a software or compiling or whatever, it changes over time. Not because somebody mischievously changes the code on your laptop while you're asleep. No, because everything you do depends on so many other things that keep evolving. Try running. I remember a colleague, Vic, did once a presentation in a lightning talk in a conference trying to build Postgres 95.
Right.
Try to build Postgres 95 today. It's impossible because it depends on so many components that are now evolved in an incompatible way that you won't even your best choice is probably to get some very old Debian repository archive and install on a VM that runs like Debian like in 1997.
Yeah.
Then maybe you'll be able to compile. So things change a lot outside of our hands, right? So it's really important to be able to validate continuously and detect breaking changes, because you may not do anything wrong, but somebody else does something wrong, and then you pay the price, right? So testing is super important.
Exactly. Yeah, adding support to a tool really just does solves the problem at that time, and like keeping the tool that is still supported complete as a whole thing in the project is really hard. I remember mainly this part that we spent most was like maintaining all these things and keeping all updated and making sure all the scenarios work, all the setups work, all the architecture styles work. That makes it repeatable, as you say, for customers, for our colleagues to train, for us to develop the future and make sure it's working. Pretty much anything when it comes to Postgres management. And I think that's why it was for me kind of a magical tool when I was transferring from just being DBA to also, started development, tooling development. And because like that's what you do day to day, and a tool that gives you this thing, and you can do it on a scale with different customers, different settings, and all this architecture that supports it. And you can also see that problems because you are the first user of it, and you know the knowledge of the Postgres and the environments of the people and the customers, and then you can just actually edit it that fits for them. And in that regard, I think it's quite unique, and I don't know if any other tools like that, because I didn't work with any of them like that, but I'm really happy that there's this tool that can actually support many projects under. Okay, I think we talked a lot about TPA, and I hope we maybe convinced few people to try it or look at it. It is available, open source. And if you use it, let us know the feedback. We can even take the requests, perhaps. So we are happy to discuss anything about it, both of us. Okay, maybe then we can talk about the usual topic that I bring up with the in the podcast, the extensibility. So what kind of extensions that you like? What are those that you feel that are really important?
Well, there are many extensions in Postgres, also because many tools usually have a piece of the code which is server-side. So they have their little extension that is companion of the tool. I think probably one of the most amazing examples here is the BDR extension, because it can transform Postgres database into a node in an active cluster. Without having to recompile Postgres, without having to change the way it works. It's just an extension that you effectively create with a single command and install it with a package like many other things. So that actually speaks a lot about the extensibility of Postgres. Of course, there are some additional features that require modifications to the Postgres database itself, which it's a common pattern given that given the license and the open source form of Postgres. It's common practice that people modify the code, patch it to have their own variant of Postgres that does additional things. Mostly this is because some features can't really yet be made into an extension, but also there are cases like EPAS that my company makes that is designed to be compatible with Oracle, so it cannot be identical to Postgres, otherwise it wouldn't be compatible with something different, right? So there are lots of cases, but I find it amazing that the extension system is so powerful that just an extension can enable active replication. And it's, even with those specific specialized features missing, it still is a complete and robust and reliable active replication system.
Exactly. Yeah, it's amazing. And yeah, like when we think about the extension topics with the previous guests as well, like we can pretty much do Postgres to anything. Like you can support a different use case. You can make it, as you say now, with the PGD extension, BDR extension. We have the active distributed Postgres. And we also talked before, like, about PostGIS and how it brings the GIS capability to Postgres. And now the popular one, PG Vector, it comes up pretty often. And yeah, like it is kind of endless, like where it can take you, and the core of the Postgres is so like extensible and always comes to that we can actually use it pretty much for endless scenarios. And it's always an amazing topic to ask. But yeah, I'm happy that you brought BDR, the Postgres Distributed, to the discussion. Okay, so...
Yeah. I think about what you said about PostGIS. I remember once attending a conference. It was a year, but many years ago. I was speaking about Postgres together with Simon in a PostGIS conference,
Okay.
and that conference was actually 6 times bigger than Postgres Europe, but back then,
Wow.
PGConf EU,
Wow.
right? So I realized that and PostGIS is actually an extension.
Yeah.
Again, so by having Postgres extensible, you open up different use cases, like in that case, the geography use case. And what happened then? Postgres was born from zero in the geographic arena. Then somebody made the extension. I mean, somebody. I'm not meaning to undermine the people that made it, but what I mean is that people interested in that particular use case, they made the extension without having to necessarily build the database from scratch.
Mm-hmm.
Then it ended up usable and flexible and powerful, and it ended up becoming dominant. Nowadays, pretty much every geographic organization uses PostGIS.
Exactly.
And this has brought a lot of additional investment to Postgres. You mentioned PG Vector. That's the same thing that will probably happen
Yep.
now with AI, or in general, having a robust and reliable database, which is open source. People can know it. People can become expert of it.
Mm-hmm.
There's now an ecosystem of books, of documentation, of training, of experts, of companies. Now there is an ecosystem that is actually thriving and growing. So people that need to store some data somehow, they're better off going with Postgres than with something else.
Exactly. You mentioned books, and of course, I will bring up the book topic.
Oh yes, okay.
So I seen the queue in the post. So for the PostgreSQL queue this year, it was. I mean, last year now, it was in Prague.
Yes,
And there was the queue for the book signing. So you were one of the celebrities. I see
yes.
you and we were. So tell me a little bit about. I mean, tell everybody a little bit about the book. I read the different versions of that administration cookbook. Now it is Postgres 16. So perhaps you can actually,
Yeah, the book was started actually without me by Simon Riggs
Yeah.
and Hanno Krosing in more than 10 years ago. So I mean, it's like vacuum freeze. You forget the year after 10
Exactly.
after sentence. You don't need to remember exact dates when it gets too far away. So that book covered a very important use case, which is to allow newcomers to find a written reference. I think a book is very different from a blog, because blogs are easy to edit and fix. So this sort of means that people may not necessarily always double test carefully everything that is written there. And it also means that you can have viewpoints that may not be necessarily reflecting good practices. But a book is not only made by the authors, and this time we actually have 5, the highest number ever. But the reason we have 5 people is because then we are able to make the book quickly, because we do a little bit each, so that people can have the book on their hands only 3 months after Postgres 16 is released, or even 2. I don't remember exactly, but I think it's probably 2 months than 3. So it's very important to get the book out as soon as software is available, and not make a nice book about Postgres 16 when Postgres 17 is the thing,
Yeah.
The book is written by 5 authors, reviewed by reviewers. It also, in the various sections where you have to thank people, or I only think my colleagues from whom I learned a lot, because I feel like the hand that wrote the book, but I'm not necessarily the brain that accumulated the knowledge. Given that we need to speak with metaphors, we are usually the dwarves sitting on the shoulders of the giants.
Yeah.
I was in a position to the book, but this book is some sort of a synthesis of a community, and not necessarily community. We talk about the community later, but has been that I could focus on Postgres first priority for so many years. And I was exposed to so many real world or customer scenarios that I don't think many other people had the same possibility. They may have done amazing things, but not for 15 years,
Exactly.
So I ended up being the veteran, which is why I adopt a healthy lifestyle and try to relax.
I understand what you mean, but you are right. I also felt the same way when I joined, the second quadrant where we were working together. I am literally sitting with people who develop the features that I'm using, and I can ask them what is the decision behind. I can just get the whole knowledge, just maybe talking 15 minutes about some topic, I can actually go see the whole history of something. And it's really valuable. And then there are a lot of people like that in Postgres community, because it's like, how many years now? 30 years long project. And you are in it for most part of it. And for me, like colleagues like you, and I felt like such a privileged person to be just there. And now again, I also feel like I'm talking about Postgres for more than 10 years now. So, okay, maybe I also accumulated, but it's important. It's important. Yeah, it's important to stay and accumulate and share the knowledge. But I think writing a book is like, of course, we are using the collective community knowledge, but curating it, collecting it, testing it's a lot of immense effort there. So again, for everybody who is in the community, I congratulate all of you. And I still haven't read the book. I'm waiting for you to bring me a copy to Prague, as you promised.
I will.
Okay.
Because the 50 copies of the signing were first and foremost for users.
Exactly.
And as opposed to to ourselves, you need the book less than the other users, so you will understand why you didn't get it in the first.
Okay.
In the first round.
Okay, I sacrifice my 50 book chance. Okay, so like it brought. I'll get it. Okay, so for the community, we always come to this point too, and we are both really community oriented as well. So like, what do you think about the significance of the community contributions, like in the open source community in general, in the Postgres, and how can we get more people involved, more developers involved?
I mean, the community is the reason that Postgres exists. I've been watching the community for a very long time, as you all know, and I can really say from direct experience that there are robust and well-tested rules and practices that allow the effective cooperation between people that do not have the same boss. So that's a very important thing. It doesn't matter what is your job, who is your employer. Some of the features have been written by cooperation between people that answer to different bosses, or that don't even have a boss. Some of them, just maybe doing another job and not necessarily related to working in database arena. And the process is so well organized that I think, Postgres is not only an example of a database, but it's an example of an amazing open source project that is now very reliable in delivering timely features. It has a process that everybody understands. The alpha, the betas, the release candidates, the commit fests, all these things that we can't go into too much detail now because this is a podcast and not a
Hacking
fancy
Postgres
series.
Yeah, exactly.
Exactly. But it really is reliable, and so many businesses and users worldwide rely on the fact that it's timely releases, and they can build their own business on top of it because it's predictable. You will get a new Postgres every year. You will get bug fixes. You will get releases in the process that we now understand. Now, my idea of community is not all the people who contribute to Postgres, even if it's not their main job. It's not even all the people who contribute to Postgres and are paid by a small company. It doesn't matter who is your employer, whether you have an employer or not. You are community because you contribute to Postgres.
Exactly.
And the rules that exist in the community, they allow people from different backgrounds, but also from different employers or from different jobs, to work together without ending up in embarrassing situations, conflict of interest. The word meritocracy is abused, and it actually means the opposite when it was first used in a book by very smart political scientist in the UK. But I would say that in Postgres, if you do your work well and you pay attention to the feedback of other people, your chances of getting your patch committed grow a lot. I will not say more than that because there's lots of factors, like takes a lot of time to be experienced of things. You may have chosen a problem that is too hard to solve, or it can't be split in smaller problems. So it may be your chunk of the problem is too big for the time span of Postgres. But remember, we deliver a release every year.
Exactly.
So it's not really possible to do a 5-year project unless you split it into smaller pieces that can fit together. But so far, all that we've done has been compatible with this model. And honestly, I don't see a single project that is too complex to be ever done in Postgres.
True, yeah. Like, of course, there are, like, as you said, the features that touches so many moving parts of Postgres, or like, multiple things at the same time. And that is harder to build, maybe. And it usually goes over different releases. But yeah, every release will bring something, will fix something. Yeah, it's not like
But look,
once in a while.
Gulcin,
Yeah,
if it's too hard to fit into a release because it touches too many things, maybe it's also too hard to think about properly, and it's also too hard to be done, right? I'm not saying that we should give up and do only the simple things. I'm saying that trying to simplify the problem and splitting it in sub problems is an important and main part of software design.
exactly.
It's not if you end up making a patch that changes 40% of the Postgres source code, or I'm just making up numbers, 40% is impossible. Let's say that you make a patch that touches so many different parts of Postgres and it cannot be split into a smaller, and you haven't split it into smaller projects. Well, most likely you didn't do a good job, because it means that you were unable to think modularly and to split your work into pieces, right?
Yeah.
So I think I'm a big fan of complexity becoming simpler by proper simplification. Not more than appropriate, but I think I've worked in mathematics for another 15 years before Postgres, doing some research in algebraic geometry, and I can probably say that I've seen complicated things. So I rarely enjoy additional complexity beyond the one that you have to do because of the complexity of the problem.
Yeah, like dividing the problem to smaller pieces, I think, is the biggest part of problem solving in many specialties, right? Coming from the mathematical background, I feel the same. I understand, I share the sentiment, but yeah, I didn't want to sound too harsh for developers who are actually, building big patches. It's really hard. It's a struggle.
Of
Yeah,
course.
and that's why the community involvement, because there are always people who have different perspectives on it, develop the same things or similar things with touching the. So it's really important. And the main thing overall, the years that I'm working professionally, what I realize, it all comes to the communication. Like people who are able to communicate the technical challenges and then discuss with the people, that there's a bigger chance that the patches will be approved. But it is hard because we're all coming from different backgrounds with different experiences, and I think the community is beautiful because of it, but it is also, as you say, conflict of interest for different purposes, or just because different backgrounds will happen, and it happens. Okay, so what do you recommend for the new developers when they decided to join Postgres development? They liked the podcast and they thought, okay, how can we join? And what do they should learn? Where should they start?
It's an interesting question. Like today, people open the TV and there's all this cooking show and talent show where people go and sing and they cook everything that they have. But their actual point is that in order to be a good singer, you need to listen to a lot of music first. In order to be a good cook, you need to eat a lot of food and taste it. And I can make examples as much as you want. So I would actually recommend start, if you want to become a Postgres developer, start by reviewing patches from other people. Do not start by writing code. Start by doing that. There's a lot of contributing to Postgres doesn't mean creating lines of code. It also means that, but it also means reviewing the lines of code created by somebody else. It means running conferences. It means writing books, talking at conferences, putting your time and effort to actually attend them. It means organize local events, help other people bridge the gap between themselves and Postgres. It means a lot of things. It means work for a company and then use Postgres instead of using something else. Not because you have to use Postgres, but because it tends to be the best solution when you need that kind of functionality. So authoring the code is like being the striker in a football team. Everybody wants to be the one that scored the goal, but if you only put a striker and there's no, and you take away the other 10, you're really likely to lose the match. So I really recommend that people use the software initially and then maybe think about modifying the software, because there's a lot of people that design tools for let me talk about high availability. So at least it looks like I'm not making fun of other people, but I'm making fun of myself. So there's a lot of people that design high availability tools and actually don't use availability tools, so their design becomes a little bit awkward or theoretical, and we already discussed the difference between theory and practice. So you should start not by writing the code, but by thinking how the feature should work after. So in a sense, you should write the documentation first, the manual. Suppose that the software exists, then the manual will look like this. And then later you actually write the software to match the manual that you've designed. This kind of thing. You will not be able, as I said before, to design a good bicycle if you never rode a bicycle in your
That's
life.
true, yeah.
And also at that point, don't take it too big. Focus on an area that you have expertise with. Geography was a great example. People were able to build an incredible thing with PostGIS. I mean, if you're a mathematician, pick AI or maybe geometry or even PostGIS. There's a lot of mathematics there about the areas, the calculation, the geoids and everything. Pick an area that you like. Maybe if it's something that you need for your job is even better. Because
there's a real motivation there. Yeah.
Yeah, also in holiday you may want to do something else rather than but focus on a specific topic and something that you know, because also you need to have to be experienced to understand what is a useful problem to solve compared to a problem that is nice to solve but not very useful. And this way you'll be able to contribute. Even if you don't know the entire source code of Postgres, you know that little part that is sufficient to solve that problem, and that's how you will start. And then things will continue from there.
It's such a good advice, yeah, because like when you this question comes to me in the when I give talks in different conferences as well, not just Postgres conferences. How can we start like in IT? How can I how can I be a developer? How can I do this? But just choosing something and sticking with it, then you will, if you don't like it, you can always switch, right? You don't really need to, okay, maybe let's say in the Postgres example, you said that you were focused on high availability, right? But then it involves more stuff in it. It kind of grows. Like there's replication aspect of it. There is like upgrades. There is like the disaster recovery, backups. It's just a huge thing. But you can start with what you know and you start learning from it. And you build up to it, and the knowledge never goes away. It will be always with you, and it will always give you different perspectives. So I think where to start, exactly, like just pick something that is interesting to you, either by motivation, by your own motivation, or maybe your customers, your company, what you need. It's a real need there, then you can actually take it somewhere.
Yeah. I think one Postgres project moves ahead by people convincing other people that it's a good idea to do certain things, which means they don't do what they want all the time, which is a good thing. Because if Postgres did all they wanted all the time, it would probably become a very useless project. So it is knowledge that you acquire today, and it will be useful for many, many years. So actually, yeah, if you are a newcomer to the IT arena, like a recently graduated student or somebody who's trying to find a job now after doing something else before, I think investing your time in learning Postgres is a great investment. I'm using a lot of the things that I learned 15 years ago or more recently. This knowledge is probably useful for the next 15 years, and I only build on top. The only thing I had to keep changing and forgetting is the things that you can't do, because you can't do certain things, and then 5 years later you can. So you have to keep losing your constraints and limitations as time goes by, which is probably good advice in life anyway.
That's true, yeah. Yeah, experience. Again, I wanted to ask, what are the best practices or tips can you offer to others working with Postgres, and in terms of performance and scalability, because it's a topic that it comes often and it really affects all of us. So I think performance and scalability. A few words about it.
True, yeah. Time is not infinite, so people want to do more in the same time. It's the only thing you can't easily buy. So, and also there's another point. If you can do 10, you will do 10, and the next day you will need to do 11. So you never. It's not like food. Oh, I need that much to survive. I have that much food. I don't need more. Performance grows. Demand produces additional demand. I think Postgres is open source, so it also has the philosophy of reusing operating system components like the IO subsystem, the disk layer. So I suggest that you understand how. I mean, the listener I know you understand already. It wasn't you. Is you that are listening, and if you don't know these things already, I suggest you learn how Postgres uses the memory and the disk, the shared buffers, the wall, and everything. So at that point, you can even use certain extensions like PG buffer cache that allow you to visualize in a view the content of the shared buffers. And then you can adopt simply the scientific approach. I think Galileo Galilei is one of the best mentors if you want to learn how to work with Postgres, despite Galileo never knowing it because he died some 100 years before the first computer was invented. But I think the scientific approach is still a good bet
It is valid.
after all these centuries. Yes, because you tend to have a theory, like Galileo was suggesting. If your performance of your database is not what you like, try to make a theory based on what you know, and then create an experiment to maybe confirm your theory. And if your theory, if the experiment agrees with the theory, then the theory is more likely to be correct. If the experiment disproves the theory, then you need to fix your theory. Right? So this is very good advice, and it ages well.
Yeah, that's true. It will always be there. Okay, I am happy that our discussion got elevated by including Galileo here. Okay.
Galileo is important for
He
Postgres. I mentioned it in the
is.
keynote at the Postgres Swiss conference, because the Swiss Postgres conference last year, happened to be on my 50th birthday.
Oh,
So I did give a keynote speech, and I mentioned time. And I think the point about Galileo is that he was born before the change to the Gregorian calendar, and he died after that. So if you actually look at the birth date and the end date, it depends on which Wikipedia you look. It differs by 11 days.
okay.
And this is also explained in Postgres documentation, because when we talk about the way we measure time, we have to mention the Gregorian calendar. Right. The political tensions in Europe means that some countries were very happy to follow the Pope. Some other countries say, no, we'll keep doing the time the other way. and then for a while, if you had cities that were like, for some city was December, for some other city was January, this kind of funny things. But this is to say that Postgres, Galileo is a good quote for when you talk about Postgres, because the scientific method, but also because you can properly compute the number of days that Galileo lived by using Postgres, if you're careful.
Here we go. Okay. Cool. So, okay, one of the last topics that I wanted to bring up is the security aspect of the database management in general. What are the top security considerations when you work with Postgres, and how can the developers address them effectively?
Security is important, of course, because nobody likes having their laptop hostage of ransomware or no longer porting the data. But I think the problem with security, what makes it a difficult subject, is that it's a negative department. It's defined by what you don't want to happen. So it's a little bit like you say, rather than how can I stay healthy, you say, how can I not get sick? So you have to predict all the possible ways that you can get sick, and then for each one of them find a workaround. So therefore, it's very difficult to say I'm 100% secure.
Right.
But what you can do, you can have some best practices that are known to be very effective in raising your chances, especially things that are easy to do, but they produce a very big increase on your chances. For instance, I think the principle of least privilege is very important. It means that when you grant privilege to a function, to a user to do things, you grant the smallest possible privileges that are sufficient to do that thing.
Right.
There was a time when we wrote hot standby, but other people wrote big we, not me and Simon.
Right.
We wrote replication with lots of people. The various pieces of replication, the streaming replication was done by another team in part. Anyway, when these things were written, initially you needed to be a super user in order to connect. So the standby node needed to be a super user account on the primary node.
Right.
Which means, unless passwords are stored in another way, you get a binary copy of the database, so you can look at the past. But also, you somehow, I think it feels too much that a standby is able to connect as a super user to the primary. Yes, it's true that you can prevent that connection, but to knowing the password and having the user, even if there is a setting that prevents you from actually connecting, it feels like a little bit too much. So this is a trend in Postgres that has been going for years now, to reduce the privilege needed to do certain actions by creating specific privileges that are tailored on those actions, so that almost nobody needs to be a super user.
Exactly. Now we have replication user for example. Yeah.
There was a film from Lars von Trier where there was a company and they didn't have a boss, but they needed a boss because they had to sell the company. So they looked for an actor that plays the boss. So there was no super user there. I mean, we are getting to the point where there's no super user anymore, almost. The super user is only the person that installs the software on the first day and then gives the
Company
various
freedom.
privileges to everybody, and then that's it. Some sort of a CEO of the database that, but the ordinary administration must not be done by super user. So Postgres is every new release of Postgres, you will see some new role called PG something else. These are the privileges that do that action and only that action and nothing more.
Yeah, definitely.
Like Goldilocks will say.
What Goldilocks would say.
That action, only that action, nothing less, nothing more.
Nothing less, nothing more. Okay, yeah. That it contains, you actually bring the very important perspective to the discussion, like containing what an action, what is the impact if, let's say, something happened to that area, to restrain it in a way. So it's, I think, really important when it comes to security that first what are those actions and who has the access to that, and limiting them unless they only need to know basis. Like you don't need to share all this information.
Need to know basis,
exactly. You don't need to share everything with her.
Yeah, it's such a good piece of advice that they follow it even outside of Postgres, you see.
Right, exactly. It's important. Okay. And we talked a lot about how Postgres evolved, how the community grew, and how it started with everything almost. And what do you think about the future of Postgres? Like, what are your thoughts on the future of Postgres?
Well, to keep it short and therefore more impactful, I can say that Postgres will keep growing like Linux, and then it will become the standard database.
Okay.
I'm saying the standard database, not the standard relational database, or not the standard open source database, because Postgres is already the standard open source database. But the actual reason is more a logical/technical one. The fact that Postgres is great for relational workloads doesn't mean that therefore it's not great for non-relational workloads. It's a little bit of a misconception. People think when they see Postgres, generic database, and then they see another product which is dedicated on a specific use case, and they say, oh yes, you know what, that specific software will definitely be better than Postgres because it concentrates on such a small niche. It's like saying that, I don't know, a good football player can play volleyball worse than somebody that cannot play football, right? Because, I can play football. You cannot play football. Oh, because you cannot play football, then you must be better at volleyball. It doesn't actually work this way. If you are a good football player, you're probably likely to be good in sport, to have fitness, to be trained, to control your body well. And all these qualities, they go well with football. They also go well with volleyball.
Probably.
And with many other sports, right? My point being that if you have a Postgres very, very good, it's not very good because one day we sat at the table and decided from now on we will only do relational things very well and we will make sure that we do badly everything else. No, we actually make very well storage, memory, optimization. We have a code base written very clearly, well documented. Developers are forced to write their own documentation because otherwise the patch is rejected. So things are documented very clearly because they're documented by people that, surprise, actually know how the thing works because they made it. Yeah, I have to make a joke now from Achille Campanile, a playwright from Italy, my country. And he wrote a book like Tragedia in due battute, which means 2-line plays. Theater plays that are only 2 lines.
Okay.
And one of them, there is a woman asking a man, do you have experience with children? And he goes, oh, of course, I know how to make them. Right? The idea being that the makers are very expert on something. Obviously, the joke there is that it doesn't apply to everything.
Right.
In the fact of Postgres, the fact that you actually know how it works puts you in the position of being a great user because you can actually look at the source code, see how things work. The source code is for every 70% of code, there's 30% of comments, which makes it very clear to follow the logic and what's going on. And I think that's really the important bit.
Yeah.
Because you have a database that is easy to work with, that does what it does well, very well, like Cherubino. This means that if you have to do something different, you already start with an advantage.
Exactly.
Right? So I wouldn't use another database to do something different. I would rather extend Postgres to do the new use case, unless it does it already. which is usually the case. I won't say much more, but I remember some years ago, a specialized database was found to be inferior to Postgres in the task that was supposed to be the specialty of that specialized database.
Right.
There is a blog. Everybody knows what I'm talking about, but I will elegantly
avoid
forget the
sharing
details.
names.
Yes, exactly.
Okay, yeah, that's true. Like Postgres is over time. It's proven. It will be always stable. It will support whatever the case that is there. Maybe it will be, like, of course, there are like specialty things that Postgres just not support yet, but there is a way to do it probably. And it will eventually get to there. But it is, again, to make it a solid database. We can't just add everything, as you say, like immediately. We have to make sure the things that we bring is not actually affecting the rest of the use cases. So in a way, it's like both sides. Of course.
Can I have a last comment? I mean, what you mentioned now made me think about the one point that actually I heard from Simon Riggs in his retirement address at the conference this year in Europe, in Prague. He mentioned the point that how will Postgres have to evolve to scale out? Because the way we do Postgres at the moment maybe doesn't scale beyond the current size, where committers and code are just a single pool for the entire code base. And maybe one day we will have to get to a point where we have subsystems that are maintained by different peoples and they have separate commit fests or separate streams, or maybe try to put as much as possible outside of Postgres in the form of extensions. So make extensions more powerful so that there is less that you have to put in Postgres. When I started with Postgres, it was impossible to make an index as an extension because there wasn't enough infrastructure to log properly an index in the wall. That's been added over the years, and now you can add the new index types as extensions. And there is even a couple of examples in contrib in the Postgres code. So it means that you don't need to put indexes in core.
Exactly.
You don't need to grow the core source code of Postgres too much with the indexes. You can have modular. You can actually have the index API and have them there. And this is an example of how Postgres is only 1-point-something million lines of code, which is a small amount considering that probably similar software are like 5 or 10 times bigger, and which means it's quadratically more complicated to review, to test, to learn, and to contribute.
Definitely, yeah. The example I really liked that what you shared with like adding index types is not it doesn't need to be in the core, and it can just come with extensions. Like again, we mentioned PG vector, right? It broke the different type, data type, vector data type. It brings the two different types of indexes, right? And there are like several cases like this for like JSON extensions. It was before it was part of it. So like it is really mind blowing. I think I will never like be surprised how good Postgres is, because like, yeah, you can just edit, bring it. And now there is like extra table access methods, right? Index access methods. You can just add stuff. Yeah, it's also cool. One. Like you can just do it. And it's amazing really how much impact you can bring it just by adding an extension, bringing something.
Yeah.
Okay. Well, that was a nice closing, I think, words. And would you like to say anything else for the listeners and for everybody who is in the Postgres community or everybody else? And we would like to say thank you, of course.
Well, yes, of course. I want to thank everybody for having spent 1 hour of their time listening to this podcast. And I will encourage them to continue using Postgres and working with it for the coming decades.
I will not say anything over it. It is like the perfect message. And thank you, Gianni, from me and from I'm sure from all the listeners will agree. It was a great discussion with you. And I hope to see you soon again.
Look, thank you, Gulcin, for having organized this series of podcasts. You are a wonderful host because you have a talent of conducting the podcast, but also you know Postgres very deeply. So this is.
Thank you so much.
As I said before, you need to know your topic before you talk about it, and you definitely do. Thank you.
Bye bye.
Bye bye.